use this presentation to introduce the course. So let's see the course overview. The course overview will show the 5 modules of the course. So the first module is introductory module, mainly to motivate the students and to let the students know what is spatial-temporal data. So we will use several real case examples and using data so they can have a better feeling of what is spatial-temporal data. In this first model, we will use 3 different use cases, one related with crime, because crime has always a very spatial and temporal dependency. So we can take advantage of, for example, I don't have data from Asia and from Thailand and from other countries there, but for example, UK police has a very good data set of crime in England. So we can take advantage of that, and we have all the crimes for every day, every month, in everywhere. So we can use this temporal and this data as the first examples. And they also have coordinates. The data is anonymous, but is quite precise data. And of course, the second example, we can use the coronavirus spread as also a temporal data, and it's also very used in these spatial temporal use cases. And we can use the data from Johns Hopkins University that has reports from cases all over the world. And the third example for this first model will be using moving objects. Moving objects is also a very common use case in spatial temporal data, and we have many data sets of moving objects, people, animals, but in this case I select the ships. We have a very detailed data sets of ships moving all around the world, because all ships has a AES system, so every ship is tracked, so we can use this data. Also in this first course, we have some introductory concepts like the definitions, properties of spatial temporal data, and also a remark for some problems with this spatial related data, because it's not very difficult to lie with maps and to create wrong maps and wrong visualizations with the data. And we'll do a remark about this danger problem using spatial temporal data. The third model of these 5 models is related with the clustering, let's say. So we'll not dig into every kind of clustering techniques and so on, but at least these two main algorithms we should work with the students, the k-means and the hierarchical clustering. I also report here the software that we will use. We'll try to use always very nice interfaces, either using QGIS or Jupyter, so the students can have a better interface to interact with these algorithms. So the idea here, using these clustering techniques, is to have clustering applied to spatial data, where the spatial plays a role, and we can use the native algorithms of KGs, the k-means and dbScan algorithms. And we can also use more simple algorithms just based on attributes for clustering, either also for k-means clustering and also for hierarchical clustering. But you can give also other references, and if people willing to do or use some alternatives, they can use the SciencePy library directly on Jupyter, or a software, very well-known software called GeoDA. It's created by Luke Anselin, which is a very well-known scientist in this data analysis. And we can also use a data set from the University of Chicago, also collected by Luke Anselin during many years, and we have very nice data sets of patterns, so we can find patterns on almost all kinds of data sets. And that's the contents for this second model of the course. And in the third model of the course, we start moving and trying to have the students more involved in the exercise and doing things by themselves. So we try to show how the things work in the first two models. And in these third models, they are invited to pre-processing some data sets, because usually we don't have the data as we would like to have to do the processing. We always have to change lines from columns, to change data types, to do some pre-processing before. So in this third model, the idea is the students to go to Jupyter and to use pandas and use data frames and transform the data so they have the data as they need to do the algorithms on top of this data. So the idea is to have many exercises here so the students feel comfortable pre-processing data and preparing data for spatial temporal data analysis. On the fourth model, the idea is to explore the visualization. So we start the typical graphical visualization using matplotlib or and other libraries on top of Python. So we can use Jupyter to start with these visualizations, starting with 2D visualizations, just this kind of visualizations, but then moving to three-dimensional visualizations and four-dimensional visualizations and so on. Also, the idea, after feeling comfortable with the graphical representation, start using geospatial visualizations, mostly using QGIS, and try to create proper visualizations of geographical data. And then in the third part will be joining the two things. So they have to do proper visualizations in space, but also using the temporal component of the data, and they should do proper animations for crime scenes, for coronavirus, for moving objects, and so on. So they can join the two components, these two dimensions, the geographical and the temporal dimension of the data. And finally, the idea is on the fifth model of the course, they develop their own spatial temporal data project. So the idea is to select some available data and pre-process this data prepare it with pandas, with Python and so on, and then do some nice supervisor and unsupervised classifications on the data, and afterwards provide a nice visualization of their project. So this is the overview of the course, and if I change to the spreadsheet where this is all, so this model 1 is this one in the first week. I hope you are able to see the screen. So the course is, let's check the major major indicators of the course. This is a 3 ECTS course. It's supposed to have 90 hours of work from students, and the lectures I've mentioned are these 20 hours of lectures, and the lectures and the lab sessions are all here. So for even before the first models, we invite the students to prepare their computers with the all required software. The required software is all open source solutions, so there is no licenses, so everyone can install Python, Jupyter, QGIS, and Postgres plus PostGIS to handle the spatial component. And these first, these 2 lab sessions of the first model are the ones dealing with the exercises I already mentioned. Exercises using crime data, using epidemiology data, and using moving objects. Then we move to the second model related with clustering, and here they have to do clustering exercises. Then they move to the third one where they have to prepare data sets for analysis, and the lab sessions are more related with the Jupyter usage and pandas and everything. They have to do a lot of small things to prepare the data sets for visualizations. The model 4 is also here, and the exercises are more related with visualizations, and here we want to explore the ways that we can communicate this spatial temporal data. And finally, they have on the model 5, they have to prepare the project and to discuss the project that will be also used for evaluation. So this is an overview of the course. Yeah, there's the software requirements for the course. As I said, it's all based on open source software, so every user can create their own environment at home or in their laptops without need to install licenses and so on. And I think the rest is already, the rest is already contents of the course. So this is the course overview. So if you have any questions, things that you would like to discuss, feel free.
Thank you. Josh, maybe you stop sharing the screen, okay?
Yes.
Can I ask? Okay, so thank you very much for the content. It's very clear, the topics and the subtopics, and the weekly plan. It's very informative. I guess you can share it with the in the chat space so everybody can is it, will it be available? Your weekly
Yes,
plan that you showed at the end of this presentation?
yeah, yes, sure,
Yes,
sure.
okay.
The contents are already prepared. I've sent to Paulo, but I will manage with Paulo, who will do the upload.
Okay.
The upload was done.
Okay,
can
okay, thank
Already
you very
done.
much.
Okay.
Yeah, already
Good,
there? Okay,
good.
thanks. And in the course that we are going to offer, we mentioned that it is a 3-credit course, so 45 lecture hours, split into 30 lecture hours, and the rest as the practical, the lab sessions. So, but seems like this is more towards to practicals or the involves lab exercises. It's better. What do you suggest? Better to do it as a complete lab sessions while theory is doing. Meanwhile, we do the practicals like the applications and tools. What do you suggest?
So
It's not clear. Okay, I'll explain it again. So in the syllabus that we
yes,
mentioned that it's 3 credits, so which means in our setup it is 45 lecture hours.
okay,
We have split it into 30 lecture hours and the rest as the lab sessions, so lab
okay.
hours. But
Yes,
this course is more towards practicals, right? More towards
right.
tools. So I feel like it's better to do it as a lab session, all the lectures, while giving the students the theoretical knowledge while we do the applications. Do you think that will be that setup will be okay?
Yes, yes, I think so. I think this kind of data, they need many practical work to feel how it works and to feel the difficulties of the data. So that's why we didn't introduce a lot of concepts, theoretical concepts, because it's difficult.
Yes, yes.
The statistics behind spatial temporal data is difficult. So we try to use only the main concepts and explain them and do exercise, and even just using clustering and simple clustering without going into details of the statisticals behind it, because it's has a lot of mathematics. So
Yes.
for this kind of course, I think we can only explore some theoretical concepts, and the rest must be practical. Because it's for people not used to create maps, not used to create visualizations and so on. It's difficult to start. So we have a steepest curve in the beginning, and we have to do a lot of exercise with the students and to go and to start with. That's why we have a very important part of the course related to the practical. But the idea is to prepare the lab sessions. So for each exercise, they have the data set where they have to use the tools they have to use and so on, and they will do the exercises by themselves, but everything is prepared.
The assignments you mentioned, assignments in every week, I guess, starting from the
Yes.
second or third model. Do you have any examples or any templates of assignments that we can refer to just to get an idea how these assignments will look like? And also the assessment criteria.
Maybe I can share exercise. I have exercise from this course on GitHub. So the idea is that they also use GitHub to report back the exercises, and also the exercises will be public for everybody. So the idea is the exercise to be written in Jupyter, and in Jupyter you have the documentation and the code in between. So everything is in one document, and the idea is to that each of these exercises will be done by each student, and they will publish their own exercise on GitHub with their own visualizations and so on. Because every exercise will be different from each student. Each student will choose the calls, will choose the way they want to visualize things. But I can show examples of things like this that I have already done using GitHub, and students report back on GitHub. So everything, and even students can see what other students have done, so they can compare, they can improve their own exercise with different ideas. But that's
Okay, yeah, that
the
will be
goal.
great. Yes. And in the final assessment, so there will be more percentage for assignments, right? Will be
yes. The idea is only the last one will be used for evaluation for
the project, the final project.
the final
Okay.
project.
Okay. Thank you.
Thank you.
I have one more thing. In the market share, the GIS history products actually have high market share. Do we need to introduce history products like ArcGIS? How do you feel that? Because when students step into the market, so there will be more history products. So do you think we should introduce that one also to the course? Like ArcGIS?
Sorry, I didn't understood
Right. Okay. Basically, S3 products like ArcGIS products are
yes.
in the market highly. Like I think more than 50% of the market share. So, do you feel we should introduce like ArcGIS like tool to the course? How do you feel it?
If we use a commercial tool, we always have the problem of managing license and grant license to students, that so they can use this license at home. The idea is here is more focused on the concepts, so they can really understand the concepts, and afterwards they can use these concepts in any tool. For example, relate to this classing techniques, for example, I suggest to use QGIS, but I also have pointers to other tools. They can use SciPython, they can use Geoda, and also they can use ArcGIS for this same task. But the idea is to present how classing works, and it will work in the same way, either using ArcGIS or using QGIS. But I don't think we need to explore all commercial tools, and if they know the concepts, and if they know how to use these concepts in QGIS, for example, they will manage to handle this in ArcGIS, for example. I think, yeah.
It is important to mention that usually we have a long tradition to use open and free software, okay? Not using commercial software. Of course, we know that the market have a lot of different options that obviously and probably our students will use when they go to the market, of course, but most of the open source, the free software that we can use have more or less the same approach, more or less even the same appearance, if I'm not wrong, George. And that's why we prefer to use this software, even because students can use everywhere that they don't have problems with that. And we believe this is a more democratic approach in which everyone can use the same software without problems and unify to everyone the use of the same software. Okay, but of course, if you have the license, they can use that in a specific course in a specific university. Right, George?
Yes, of course. If you already have students with a setup using ArcGIS and so on, it's just a matter of changing the lab sessions, and instead of using QGIS, for example, using ArcGIS. ArcGIS has a very nice toolbox for doing spatial temporal analysis. This clustering can be used exactly in the same way in ArcGIS. So it's not difficult to rewrite the lab sessions to use ArcGIS if you prefer it. But sometimes it's dangerous to use a specific tool, because sometimes with MATLAB, for example, and we see students learning how to do it, and they know the buttons and they know where to push the buttons, but sometimes they are not really understand what they are doing. And when we change the software, we make them thinking what they are doing, and let's see and how these things work on a different software. So changing the software sometimes is good, so people think what they are doing, not where the buttons are, and following is just the guide. But from the point of view of the course, it's really not important if it's one tool or another. And that's why I've pointed, I only pointed to other open source tools, but we can include ArcGIS, of course. If
we tend to do in our group to be free of software, independent of the different software that we use. That's why we prefer to use open source software. In the different courses that you have see, and from our group, you will see that is a kind of tradition, a kind of politics that we use, okay? And it is a tradition in our university to use open source software, to be independent of different manufacturers, and we think it is the correct way. And as George mentioned, it's important, sometimes students tend to take too much time observing the different buttons and they don't know what they do. So we prefer to the opposite, sometimes use bad or not so beautiful buttons, but to understand what they are doing, it's quite important. Okay.
and even I can add also for the operating system. We never mentioned the operating system, used to let the students use what they prefer. Sometimes people prefer Mac if they love the Mac ecosystem, or if they prefer Linux or Windows. Usually we don't care if the users are able to do the Python setup, database setup, QG, they use the environment they prefer. We don't impose any specific environment, and it's nice even in these courses. And this last month that we have to teach online, just online, it's nice to see that each student creates their own setup and with their own tools, and I think it's more productive if they use the tools they like and the operating system they like. We just enforce the concepts and the main theoretical concepts related to the courses. The software and the environment is up to the students.
Okay, more questions?
So even for assignments and project, is it okay for students to use their own setup and any tool they are comfortable with, or combination of tools that they are comfortable with to when they do the project and the assignments? So that's also okay, right, for students to use any tool that they are comfortable with, right?
Right.
That's okay.
Yeah, and even the data sets, they can choose the data sets and so on. It's nice, I think.
Okay, more questions?
Hi, Paulo. George, this is, can I ask question for you?
Yeah, for George and Paul and me, yes, of course.
Okay.
Yes,
This is Adef. I am Adef from University of
Hello.
Sumatra Utara. Okay. I see that from the course outline that we have some option to evaluate the component from the examination, assignment, and project on spatial temporal data mining. And as you mentioned before that, I hear that the biggest point is from the project, right? Maybe you can share or from your experience that for its course outline from the beginning, from the description until the visualization, do you have a specific metric to evaluate its topic? For example, in the second course outline, we are talking about the modeling on spatial temporal data. We discuss about clustering, classification, and predictive learning. So for this example, maybe could you please share your your experience how to evaluate the specific that when we are discussing about the clustering, classification, predictive, we can choose some algorithm related with this topic. So how we can make sure share to our student that this is the proper method for this case, something like that.
Hi, Hade. Nice to meet you.
Hi, good.
The idea is in the first and second models to introduce the clustering algorithms and to show this clustering for different data sets. And we'll use data sets with point data, data sets with polygons, and so on. And some exercises are to show that these clusterings are not adequate for certain kinds of data, and so on. So the idea when they do the clustering by themselves is to evaluate if they choose a proper technique for the data and for the use case they have selected. And the idea behind a course like this is also to during the development of the project, talk with the students, see what methods they are choosing, and see the preliminary results of the students and discuss with them if they are feeling comfortable with the results, and try to guide them to use the most suited technique for the data set they choose. So in my experience, this has to be done during the preparation of the project. We cannot let them start the project and only see the project at the end, what they did. We need some hours of talking with the students during the preparation. But usually in the first step of this project, I ask students to choose a data set they like. For example, right now we have very nice data sets from Apple and from Google, for example, from where people were before the coronavirus and after the coronavirus. So they choose a data set and we discuss the possibilities of each data set. And in this way, in certain sense, we guide them to use the proper techniques related with clustering and so on. So back to you, this is my experience. We need to guide them from the beginning so they don't use things that don't give good results. So
okay, thank you very much, Josh. That's clear for me.
Okay, great.
So adding one more thing to Ade's question, so that means we should start the project with the students somewhere in the middle of the course, right?
Right,
or maybe
right.
even earlier. So
Even earlier.
Yeah, even
so,
earlier. Okay.
The idea is after the first two modules, they start to choose the data set. So after these two first models, they already see different uses of data, different uses of spatial temporal data. So they can start and be motivated to do something with a data set they know or these data sets they are presenting. But the idea is to start earlier so we can discuss the options before they decide where to go.
Okay, thank you very much, Josh.
It was my pleasure.
Ah.
I also try to see data sets from other countries like Thailand and so on. So if you have, there
They can
are
send us
online resources.
if they want. George, you can probably invite our friends to send to us eventually some data sets and we can eventually prepare them to as the one that you mentioned before. Okay,
Yes,
it'd be
yes,
nice.
yes, yes.
Even for us, will be different. Okay.
Yes, yes.
I
For
think
example,
if you have a data set, send to us, please. It will be nice to collaborate with you in that. And
Okay. Yes,
Emil,
because,
of course.
yes, Paulo, because
Malika, sorry.
yes, because it's a good idea if we can share the specific data from our own country, because it will
Yeah,
be,
it will be very nice.
yes,
And probably it will be more attractive to your students. Obviously, we know that, and we do that in Portugal, of course, and it's natural that you do that in your country also. But obviously, these kind of things are open to everyone. We send to you the setup, and of course you can do some modification. Namely, in the example, are very nice to use the one that we have, and are more attractive for our students, because probably even for them to understand the data set will be more simple to them, because they know the data that you are using, of course.
I agree with you, Paulo, because its location has specific and unique story behind the data. Right?
Yeah, of course, of course. We do that in our country. It's normal that we will do the same. It's a kind of, we're trying to motivate our students, of course.
Yes.
And this is a trade-off, very complicated, as you know. Sometimes it's not easy to motivate our students. So
yes, because the story is different.
Right? One of the techniques that we use is to select a good data set, a good example that we can put in context in our country, of course, in our region at the end. Okay.
yeah, I was sharing my screen because I found
Bangkok.
yeah, for example, these data sets are nice because they have things like education, they have the school locations, universities, and so on. So this kind of resources is really nice for the course, because we can use this as to show students, and they have more connection with the data, so they can understand better the data. So I think if we can update our lab sessions with these data sets, will be really wonderful. I've tried to do some analysis with this data, and the data seems good. So, but I need your help to identify these data sets, and even I have to translate this page to really understand what it is here, because it's written in Thai, and it's not easy for me to understand what is here. I just download and try to understand the data, but if you can help us to understand these data sets, it will be great to use it in our lessons. This is for Bangkok area mostly, but we also there are also data from other areas, and maybe Emily has also data sets from her country we can use. We try to find some local data, but we need help for sure to choose the data sets that we can use.
More questions? Professor João, probably there is no more questions. I think we already have a very good conversation with Abe and Amilka. The other colleagues seem to be don't need new clarifications. So what should we'll do now, João?
Just 1 minute, excuse me.
Okay.
Okay.
Oh, you are in parallel with 2 meetings.
Two meetings.
Yeah, extraordinary, man.
If you see me like this,
Yeah.
sorry. If there are no more questions, you asked already, Paul.
Yeah, yes. I hope our colleagues are satisfied with our presentation, and we wish you the best, of course, and the most success that we can have for you in giving this course, and the other one that belongs to this good team. I think it was a good team that we prepare.
Yes, we have from University of Minho. Let me tell you that we have strong cooperation with a lot of these institutions, even regarding conference and some research. So I hope we can extend it more on cooperation regarding not only teaching and master courses, but also on research and the supervision of PhD students, co-supervision. We have several programs where we split foreign students that come here, always with co-supervision. The students that come here, who have the PhD, and then return back. We don't want to keep them. We are not like other countries that pick the best and keep them. So we want a cooperation that then evolves for research and development projects. Not like British, for instance, or the United States. We hope this contribution for that, and thank you for being present. Let's see you in another evening. We expect in September or October or someone face to face. Thank you, and
Thank
see
you.
you later.
Bye bye. Thank you. Bye bye.